Hello everyone, bonsoir tout le monde. Donc, bienvenue sur cette nouvelle session des Dakar Bitcoin Days, des Learning Sessions. Donc, comme vous le savez, le Dakar Bitcoin Days, c'est pour bientôt. Ce seront les 29, 30 et 31 octobre à Dakar au CISAS. Nous allons parler de sécurité, nous allons parler de Lightning, nous allons même parler de communauté, nous allons parler de plein de sujets. Et aujourd'hui, on continue ce learning session avec une session qui est dédiée au Lightning Development Kit, donc LDK, qui est un framework et je pense que ça va être très intéressant pour tout le monde de suivre. And this session will be in English, so I will let you know guys in it, I think. So I will let you start. You can start whenever you want. Thank you.
Hi, Nuru. Thank you very much for the introduction. So, my name is Anyway. Most people call me Annie, and I'm the open source contributor to the LDK development kit, specifically to LDK Node. That's a project that I've been working on for just over a year. I started working on this project because I got a grant from Trust to focus some development effort in the project. So today, for this session, I'm going to share a bit gentle introduction into LDK. But before I do so, I'm just going to share my screen, bring up the document.
Are you here? We cannot hear you anymore.
Yeah, I am here. I'm just trying to share my screen out. I would like to know if you all can see it.
Yeah, we can see your screen. Thank you.
I'll be sliding across different windows. Please let me know if it constitutes a problem, a visual problem. If not, proceed. Can you still see my screen?
Yes, still.
Okay. So I'm just going to talk a bit about LDK node in this gentle introduction. Designed this presentation in particular to focus on onboarding onto LDK node. But before we do so, the primary highlights I would like to talk about is about what the Lightning Development Kit is, then some of the LDK-based projects that we have available, LDK itself, LDK node, LDK server, and a related project called the VSS server. After that, look at some case studies, not case studies of projects that have been built with LDK based software, either by leveraging LDK node itself or LDK itself, because these are the two projects that I know production ready. Um, the idea here is not to talk about specific case studies, but to like have a general overview of the type of projects that can be built with LDK to get some inspiration, especially if one is working towards building their own product, working towards building something new or different or innovative that they would like to present at a hackathon. Whatever it is, to look at what other people have used LDK to do and to gain some insight from it. Finally, I would like to onboard onto LDK. The idea here is that we can have like a general API overview. We can talk about the foreign functions interface. The idea here is to have like a general API overview to talk about the foreign functions interface and how we can generate foreign language bindings, especially for people who do not want to work with Rust. Then maybe we can have like a test case walkthrough time and if there's interest. Why I've decided to go about it this way is because I think some of the tests that we have in the repository, they give their tests are usually in one of the best ways to onboard onto a project. Will give you an idea of what is public, what can be called, how you should call it, and how you should use it. I'll be checking in from time to time if there are questions or feedback in the chat. So please don't hesitate to interrupt me at any point in time. Either by sending a message in the chat or by raising up your hand. So please let me know, is the audio output still shaky? Is it still low?
Sometimes it's low and shaky, but when you asked me
Sometimes.
the question just now, it was good.
Okay. Is this a problem you experienced too, Alphonse, or is this just from you?
Not too often, but I think you can continue like that. It's good.
Okay, okay. Please let me know if it gets bad again, and then I'll just switch out the headset that I'm using.
Okay.
Okay, back to the presentation. So LDK is a software development kit. It is something that's been designed to be flexible, to be customizable, to be like a high performance implementation of a suite of Lightning protocols. Um, if you're aware about how key players in the Lightning space, how they design their nodes, you'll know that LDK is quite different from the rest of the pack. We have LND, which is, I think, the most popular, most used in the space, Core Lightning and Eclair. These options, they come packaged as daemons. These are software that you are meant to run either in the fore or background and then to use as is. You don't get a lot of customization with these projects. They are completely encapsulated. All the logic that you might be interested in, if you're, for example, interested in just a fraction of their total offering, you still have to take the entire pie that they offer, even though you might not have interest in some implementations that they have within their node offerings. So what LDK has done is that, hey, they've decided to give users um, more options, the ability to switch out things to say, okay, hey, I don't like how we get data um, from the chain or the block source. I want to switch it out to something else that I think is more efficient, that I prefer, that I'm more accustomed to. So that's what I'm going to do. I want to change out how we handle channel management, for example. So these are some of the options that LDK gives you. But before we dive deep and just proceed, I'm going to talk a bit about the architecture. I'm going to slide onto and if you look at the official website for the Lightning Dev Kit, you can see that it has the kit itself and um, what it lets you to customize. In general, it's Lightning protocols and what the what the implementation entails. You have what looks like this. It's like a channel, right? A channel that is anchored to transactions in the blockchain via which you can forward fast time lock contracts, in essence, or payments across nodes within the network. This channel needs to be monitored. You have a channel monitor for each individual channel, but you can also have, because these channels are anchored to the blockchain, you also need to monitor what's happening on the chain. So you also need something called a chain monitor, something that monitors, let's say, the funding transactions that Lightning channels are based off of or that are anchored to. Finally, there's something that LDK refers to as a channel manager. A channel manager just encapsulates all of chain monitoring and channel monitoring so that you can have the entire management of channels within your node. If we look at the architecture, um, what LDK offers is for you to have chain interactions. Chain interactions, if I just switch back to this, interactions that happen because you are basing off of transactions that are within blocks. The base layer is a chain transactions. So because of that, uh, you need to monitor transactions within blocks. You also need to monitor transactions or access within the mempool. So you need to have something that can do that kind of monitoring interaction to listen and also to notify. Then there is what aspects of the Lightning dev kit that has to do with wallets. Lightning um, node has to have wallet because it's the wallet that it can use to the, let's say, on-chain wallet that it can use to then fund its internal off-chain wallet, and that wallet via which it uses to create channels that it then uses to forward transactions or forward payments within the network. So it offers you tooling for signing, uh, for entropy generation, and everything that is that you find baked in with BDK, for example. BDK is the Bitcoin Development Kit, which is like a sister project to the Lightning Dev Kit. BDK has done extensive work on wallet development so that it is easier to work with if you're building with it and to integrate into existing projects, just like LDK has done with LDK node. Another thing has to do with like the systems. Like there is the state of uh, the channels within the network that you have to save because at different points in time, nodes and counterparties have to be aware of where they are. What I mean by where they are, let's say the channel state, for example, you want to know that you're creating HTLCs, receiving and sending them, in this case, having inbound and outbound HTLCs. And as channel balances are changing, you want to maintain state. You want to know at what state you are where a certain commitment transaction was revoked, and what state you expect your counterparty to be in before you proceed to the next state, which is should I revoke this current one and create a new one, stuff like that. You also want to keep track of invoices when you get when there's a request to make a payment. You want to save an invoice. You want to have like a record of the network graph or the score, some of the stuff that are important to how a Lightning Network node operates needs to store. So finally, there's other two aspects to the network that has to the node that has to do with networking and eventing. Now, as you can see, all these systems like networking that allows a node to connect with another node within the network, it's a peer, and then based on that connection to now create a channel. Um, you can only create channels, I believe, with um, nodes within the network that peers to you. Then the final thing has to do with like LDK is very much an event-based architecture system. Littered across the repository are several events that are generated with regards to when messages like protocol messages are received and when states are changed. The events that guide how node operates. As you can see, these components, especially these highlighted with the dashed white, they tell you that it is interchangeable. You get to decide what you want to use here. You're not locked into like ecosystem where it is their own networking implementation or their own chain interaction or wallet implementation that you get to use. You have the option to switch out based on um, based on the options that you prefer, that that options that you find most suitable for the task that you want to use it for. Now, looking beyond the architecture of LDK, the documentation also provides an insight on how to go about building if you want to build a node that is based on LDK. It's important to highlight that LDK is an implementation of the Lightning Network with Lightning Network protocols. That is the protocols that we have here, in, as stated in like all the boards that have been implemented to date. The Lightning Development Kit is an implementation of these protocol specifications, as well as some supporting crates to get you off the ground. If I shift back to my repository that has Lightning LDK, Lightning Development Kit, you can see that it has the Lightning crate. The Lightning crate contains everything that has to do with the protocol specification that I mentioned here. That's all of bolt 1 all the way to bolt 12. So within the repository, you find things that have to do with the protocol for channel management, for handling Bitcoin transactions and script formats, for onion message routing, for peer-to-peer node and channel discovery, and the like. Aside that, I think maybe I should just give an insight into some of it. So with regards to particular, um, let's say with regards to channel, for example, these particular Rust module contains information about um, how the protocol was translated into code. So there are things that are specifically based on the protocol, and there are things that are like attachments that you have to add along so that you can capture what is software required but not specified in the protocol specification. So you have majority of that within this module, the LM module. Then the things that have to do with chain in terms of like channel monitoring and chain monitoring, they're contained here. Things that have to do with routing, they're contained here. So everything specific to Lightning is here. For example, based on the architecture that we looked at before, there are things that had to do with chain interactions. There are supporting crates that LDK provide. They're kind of like starter crates. If you want maybe like an inspiration on how to go about implementing your own or to use out of the box because they have it provided. So, for example, there's what they call the Lightning Block Sync. This particular crate is so that you can have a this particular crate is so that you can have like a block oriented chain sourcer, something that sources blockchain information that is oriented towards blocks. There's also another one that sources chain information, um, transaction sync. This one in particular is oriented towards uh, transactions. So you can have something that's based on a transaction indexer like Electrum or Electris, something. So either of these options can be used interchangeably with to the architecture diagram with like chain interactions, replacing um, getting inspiration to implement yours, whatever, you can use either the block sync or the transaction sync to proceed. That's just an example of how LDK and its architecture gives you the ability to customize, to choose what works for you. If BDK doesn't work for you, you can use some other type of wallet. You can implement your own wallet. You can use the, let's say, the the wallet that comes baked in um, with Bitcoin Core, for example. If you you prefer to use that wallet as opposed to others. Um, yes, I think that just gives us like a general overview of what LDK is and why it is built the way it is built and some of the supporting traits that LDK has. By virtue of its design, there are different like design cases, which is just like this contains like a case study of how LDK has been used in different projects. I will talk about this a little bit later. The next thing I want to talk about is some of the LDK based projects that exist in the ecosystem. Now, beyond just LDK, there is what we know as LDK node. LDK node is a node that is based on LDK, but it is packaged as a library and not as a daemon, not like LND and Core Lightning or Eclair. What you have that is a daemon that's in that same category is called LDK server. Now I have this diagram here to just capture um, what each project is, where they fit in within each other and whatnot. So you have LDK, which is the development kit, and LDK together with BDK is what LDK uh, node uses. The LDK node is the complete node implementation. However, LDK node is a library, so you can embed this library into your own project to call, have access to the node directly, and to utilize the API that it exposes internally and embedded within whatever projects that you're working on. Alternatively, if you want a daemon, then you can maybe look at LDK server. Unfortunately, LDK server is not yet production ready, but the current implementation can give you insights into the direction that it is going, and also maybe motivation to want to implement your own daemon if you are looking to go that way. But essentially, what this daemon is that it is a server that wraps an LDK node and it exposes an API that a client can make gRPC calls to get internal access to node operations, so then to get the corresponding response. So um, if you are interested in running an LDK um, based project as a daemon, I would advise that you look at LDK server and how far it
Okay.
has gone. Sorry.
Normalement, mais pour la tête, tu as trouvé une bourse, non?
S'il vous plaît, vous pouvez couper votre micro. Merci.
Sorry, is there a question?
No. This one, you can continue.
Okay. So back to the diagram we're looking at. So if we look at the LDK server project, it's a daemon. It's the classic thing that we all are comfortable with or that we know about within the ecosystem. It's like LND that comes with LND and LNCLI so that you have like a client that you can use certain APIs to interact with. LDK server gives you that. It's not yet production ready, but it's getting there. If you're interested in like maybe contributing to the project, you can give like pointers and more insights into like how to get started. But this is what I'm giving right now is like a general state of the ecosystem. LDK receives the most development effort, is the most robust, it's quite a very powerful software development kit. LDK node is based off of LDK and BDK, and it's an out of the box node that you can use, but it's packaged as a library so that you can just use it within the project and spin it however you want to. If what you want is a node running as a daemon, then you should be looking at LDK server. LDK server comes alongside um, its own client, but I don't think you have to use the CLI client because the API is exposed for you to use any which way. So, for example, you can wrap up the LDK server client in another client of your choice. It doesn't have to be a command line interface, and then proceed from there. Just to take a look at the layout of LDK node and server, I'm just going to switch into this. This is what LDK server looks like. This is the CLI. The CLI uses the LDK server, and then this LDK server photos contains information, I think, about protocol buffers are used. And then LDK server is the actual server itself. The server wraps the node. So if you're interested in like another a proper deep dive into LDK server, then you can use it. But internally, it uses, like I've said, LDK node. Still a work in progress, so maybe use it with caution. And if we're to look at LDK node, LDK node is, like I've said, it's a node, a self-custodial Lightning node in a library form. So you can, in your project, let's say if you're building a Rust-based project, you can, in your manifest, add it as a dependency and get access to the node and use it directly. It offers certain like its API is the exposed public functions, the things that allow you first to maybe having built the node, to start it, to stop it, to connect with another peer in the network, to connect with to connect with another peer in the network or to disconnect from them. Look at a list of existing channels that you have. Open a channel with a peer or to close an existing channel that you already have, amongst other options in the API that LDK node offers. So looking at, if we're to look at, just a brief overview of the, the documentation, there is a builder, some object that you use to build the node. In essence, the builder helps you to add configuration options, like maybe what type of network you're working on, what type of chain you're sourcing information from, what type of gossip you're sourcing, whether it's something that is based on the rapid gossip sync protocol or something else. And then eventually, when you are done with configuration options, you get to build the node. So when you call on build, you get this node object. With this node object, you can call different API functions that are made available to you. So you can start the node and it starts. Then you can maybe um, gain access to an on-chain payment and to create a new address. You can, having created a new address, you can you can open you can also open a new channel. Um, you can wait for events and then process them after you receive them. There are a lot. If I to open up the library, look at the node itself, this is the node object. Then within the implementation of the node object, these are the functions that are public and exposed for you to utilize in your project. Functions to start. Um, sorry, I'm not going to do a deep dive here. To stop, to gain a status of the node, to get access to the configuration object, uh, stuff like that. Like that's basically what LDK node is. Yeah, okay. I think having talked about these, I would like to talk about maybe look at an overview of what you can build with LDK. We'll look at some of the case studies of projects that are currently existing as listed on the website, those that are not, but that I'm aware of the people have built or have been building. Excuse me. So people have built wallets that maybe just rely on some functionality that LDK has, exchanges, watchtowers, liquidity service providers, like developer tooling, banks, and payment processing. I'm going to move to yeah. This contains some of the case. Can you also see my screen?
Yes, very well.
Okay, that's good. Some of the applications that people have built with LDK, like you do some banking with Cash App. Um, some of the interesting ones I've seen quite lately is like Liquid, like Fedimint is here, Lightspark is here, Lex is here, Liquid is here. This I think is for like liquidity provision within the network. This is like Lightspark is for enterprise grade work, payments on the Lightning Network. There's Mutiny, but I think Mutiny recently shut down operations, so maybe that might not be a project to look at, but it's interesting because it was trying to do some non-custodial work, and so I think build a non-custodial wallet. You can look at the case studies if you're interested in what people have used Lightning to do, LDK to do, and maybe to get some inspiration on what to build, especially for us on the continent here. So that's just like an overview of what people have worked on. I think if you've been active in the Bitcoin community in Africa, we're very much familiar with Fedimint. And I think Etawallet is built and maintained by someone who was part of the first B-Trust cohort. So if you're looking at something that's been built by people within the Africa space, then you can also look at the Etawallet project. Um, yeah, but aside some of these tools that are based on, let's say, financial applications, there are also developer toolings that people have been working on. Like most recently, uh, also a B Trust graduate or fellow who started working recently on Node which is like a tool to give you like observability into your Lightning node. And the Lightning node here that they're using is LDK. So these are beyond just what is like a financial or a fintech based application that people are building, something that is a wallet. But they're also like, if you're interested in building things outside of that, then there's an example of like a developer tooling and of ability tool that is in the works that people are building, especially people that are on the continent here. Then there's one other example I wanted to give of a kind of tool that you can build for a Lightning node. Unfortunately, it's on LND, so I don't think I'll bring it up, but I might before we close up this session today, just to show the versatility of products that one can build with LDK. Okay. If you're interested in building with LDK, there are the different options. So you can, based on the LDK project that is available, you can either have it embedded within your application and then proceed from there. make direct calls to the exposed APIs, or if you're using, let's say, the LDK server, then you can have the LDK server client embedded in your application to make the calls to the server and then to proceed. If based on your level of understanding of the Lightning protocol, your comfort with the lower protocol level implementation, then you can look at working with LDK directly. It just means that you have to do maybe some work beforehand. But the truth of the matter is that majority of the Lightning work has been done. Right? It is a very, very solid software development kit. Everything related to channel management, chain monitoring, all those things have been implemented within the kit. And now just left to you to kind of like wire the systems together. But your application typically would have an LDK based tool or software, and then the block source, which might be Bitcoin D, BTCD, or and the block and transaction indexer like Explorer or Electris, depending on which one you find most useful for your application. Finally, last part of my presentation is for us to look at maybe onboarding, excuse me, onboarding onto LDK node. The general idea here, like I stated earlier, is for us to, having looked at the API, we're also going to look at the foreign functions interface so that people who may not want to build in Rust or do not care anything about Rust can focus on maybe the language that they care about that is supported. It's one of the finding target languages, foreign languages that is supported by LDK. To do that, I just have like a small diagram to help us understand the final thing that we're going to do, which is like we're going to do a test walkthrough of LDK. But before we do that, I don't know if there are any questions at this point in time. Anyone else? Anyone talk about? Okay, if there are no questions, I did say that we're going to have like this API overview. I think I have already given an overview of the API on the Keynote. Um, the next thing I would like to look at is the foreign functions interface, and we'll be generating foreign language bindings. Now on the LDK node project, we have um, the project that looks like this. There's the source code, and the test code. There are some support scripts that are made available. Um, these things are made available so that you can focus solely on development work and not worry about all the plumbing work that you need to do to get things to work. So, for example, there are scripts to help you download Bitcoin D and Electricity so that you can have tiny daemons that you can use within your tests, maybe even within applications that you're building, so that you don't have to worry about the plumbing that has to do with wiring them up. Then, um, with regards to bindings, as you can see, LDK supports just a few languages. It supports Python, it supports Swift, Kotlin, like Android, Java, if you lean those ways. Now, for this our presentation here, I'm just going to focus a bit about Python and what is generated, what it looks like, and how, even though this is a Rust project, you can still have all the functionalities within the Rust project on the Python side, so that if you like Python and you prefer to work with Python, then you have the right thing to um, work work with, the right language to work with that you're comfortable with. So to generate it, what happens is that LDK node uses Unify bindings generator, this Unify again. And there's a support script. What the script does is just that, okay, hey, um, there's a target directory that you want to generate the Python-based code, bindings code, and put that code in that directory. So in your case, this could be like whatever Python-based project that you're working on, you can put the path to that project here and the path where you want it to output the bindings. Then because you have the binary that is generated, the unified binary that's generated, this binary is used together with something called a UDL file uh, to generate bindings for like the Python language. And then it copies the generated library into bindings into this directory. So in my case, this is where it is. And so if I come into here, bindings Python, look at LDK, I see that this has been generated for me. This file, this is the LDK node library, but the Python version of this library. It has a lot of scary um, looking classes, but the general idea is not to focus too much on these, but to look at um, the APIs. Um, the APIs here within the node, these same APIs are available to you in Python. So for example, we take a look at where the where this is called within a test file when we set up within a test file where this is called after you do like a setup of your node. When you get the node, um, you can see that it's the same start function. Excuse me. It's the same start function that you have in Rust that you call in Python. It's the same stop function. It's the same on-chain address. Give me a new address. Same those same APIs that were exposed that are available in your foreign language of interest. So you want to work with any language of your choice as long as it's supported by LDK, and you can generate what you need for it, import it, import the node into your project, and then proceed from there. Then finally, what I want to talk a bit about is on the test walkthrough. I think that tests are one of the best ways to get into a project to understand what is available and what is callable, what is usable. Um, so there's the one test I would like us to walk through is called the channel full cycle test. What this does is that it sets up two nodes, node A and node B, and it makes you fund the nodes, the wallets within the nodes, makes you open a channel, then makes you send, you send funds from channel node A to B the channel, and you get to go through the motions of the entire process of payments moving from one node to the other. You get exposure to the APIs that are available and that are called. So before we do a walkthrough, are there any questions that anyone has about what we have uh, presented so far? Any contribution?
So the thing I didn't know is even if like LDK is written mostly in Rust, you can build a project using Python and do a binding. Is it correct?
Yes, yes.
Okay.
You don't have to work with Rust if you don't care about it or you don't know it or you find it a little tedious. If you prefer Python, you can use a support script to generate findings that you need, and you'd have um, you'd have you'd have this generated for you that just contains everything, um,
Okay.
everything on the Rust side, but it's Python equivalent, so that you can make the right call. The thing to take note of is that some of the objects that exist here, they are proxy objects. They proxy the actual object on the Rust side. So when you make a call on the Python side, it crosses the interface to the Rust side. The actual Rust object makes the call, then it returns the, let's say, the function return value across the foreign functions back onto the Python side of things. So you do that into leaving crossing off the interface between the two languages.
And when there is an update on the Rust side, on LDK, let's say,
Yeah.
we'll need to update our Python code as well, isn't it?
Yes, if there's an update on the Rust side, then you have to regenerate. You have to regenerate what is what is output here on the Python side. So, like I
Okay.
said, LDK gives you some support scripts so that it's not difficult to do. So every time, let's say you're working on the Rust side, uh, and you introduce some changes and you want to test it out on the Python side, um, you only have to just run the script. After you run it, you're going to have a new updated version of you're going to have a new updated version of this file that contains all that you introduced, and then you can use that.
Okay, thanks.
Okay. Um, yeah. So to proceed with the last thing, which is like doing a walkthrough, kind of full cycle test. Um, I have this diagram here, which I just used to show that a channel is very much anchored to the base layer. So there are interactions that you're going to see as we walk through this test that show interaction with the Bitcoin layer, like maybe get an address to fund the address, to generate and send money to that address, and then to based on the money that you have tied to that address to like create a channel, create a funding transaction for that channel. Then, so yeah, essentially that's what this channel full cycle is going to contain. So I have two options here that I want to show. It's either we do like a debug walkthrough, or we just do a simple walkthrough. Which would you prefer?
I would advise to do the simple one, if it's okay
Okay,
for you.
okay. Sorry, sir.
I say the simple one, if it is okay for you.
Yeah, sure, sure.
Okay, thanks.
Is it helpful to have a full screen or to have the diagram for the slide?
Yeah, this one is good, so people will see on the side what it
Okay,
means. Thank you.
okay. So for the last thing we're going to look at today, we're just going to look at one test and walk through it together. The test we're going to look at is called channel full cycle. Increase the front. So in this test, the first thing we do is we set up Bitcoin D and electricity. That is these source and a transaction indexer. Um, Then we set up a type of chain source. So in our case, we've set up Explorer. So what that means is that the the chain interactions that I mentioned here is going to be, instead of going to maybe Bitcoin Core RPC interface to get block information or to go to lectures, the chain source would go and get information from Explorer. And does anybody know what Explorer is? Yeah, question for the house. Does anybody know what Explorer is?
Go ahead. You can give us.
Okay. Sorry, I was waiting for feedback.
No problem.
So um, there um, there are there are block and transaction indexes that we have. We have it is something that explores Bitcoin, um, the blockchain, but the blockchain as is not. I don't think. Happy to be corrected. I don't think it is an efficient um, data structure, something to efficiently navigate and to get notifications about stuff, for example. So if you look at just the blocks and the transactions within the blocks, if you are interested in a particular transaction, if the blockchain is not indexed, given the size of the blockchain, it might take quite a bit of effort from you to implement something uh, that can query for the right block data that you are interested in. So what happened is that I think they worked on a certain protocol, the I think Electron protocol that, that does indexing of blockchain data. So it could be block, it could be transactions, whatever, so that people can easily navigate and, and easily subscribe to data. They can navigate, easily search for block data that they're interested in. And it's based, I think, part of it is based on the Electron server protocol, which is not something that I plan to talk about today. So maybe we just ignore. But in essence, just think about Explorer as a tool that lets you, that's based on Electris, that lets you efficiently query for and or subscribe to data on uh, the blockchain, indexed blockchain data. So it provides you, I think, a REST API. You can make calls to get the data that you're interested in. Uh, yeah. So that's mostly it. So back to this. So if we say okay, we're interested in Explorer, that's what we want to use to source index blockchain data, then this is the chain source that we use. The next thing that we do is that we want to set up two nodes, node A and B. That is these nodes here. We want to set them up so that we can create a channel between them, or we want to set them up to connect them to create a channel and to conduct a typical Lightning Network operation, node operation uh, between these pairs, which is that we maybe forward payments from node A to B and or vice versa. We settle it, we're good to go. So that's after we call this function. There's a helper function that sets up the two nodes. Then we go into the full cycle. Um, so let's go into the full channel cycle. So um, essentially, what this does is that for a start, we set up addresses for on-chain payments that for node A and B. We need to set up these addresses because these nodes they have like internal wallet, the BDK wallet. That BDK wallet has both the Lightning wallet and the on-chain wallet. Let's just call it that. That on-chain wallet is what you use to fund the Lightning wallet that you then use to create your channels. So we want to get some money onto the wallet for both of these nodes. So that's why we create these addresses. We pre-mine a certain amount of money and then we distribute that money to each one of them. So essentially what happens here is that after we create addresses for the two nodes, we mine and we share the money, right? We try to create a certain amount and then we share it so that both nodes within their wallet, they have money that they can spend from. So after we've done that, we do a syncing of the wallet. We bring the wallet up to date with the most recent change so that the nodes, they have a view of how much money they now have. I say before we do this mining and distribution of funds, the nodes awareness of the wallet is that their wallets are empty, the on-chain wallet is empty. But after we have mined and distributed funds and we bring the nodes up to date with the wallets, they would then recognize that they have some money within their wallet. Then if you list an operation, an API that is function that is available is this function, sync wallet. These are examples that are within the nodes expose API. Yeah, that you can call to get an idea of the balances, your Lightning wallet and your on-chain wallet. What do I have available? What can I spend from there? Is it equal to the amount of money that I I recently mined and sent to myself to my on-chain wallet? So if these assertions are true, then it means that everything has gone fine from here up until here. So the test also does is just to check that the funding transactions that you see it that okay, I've created a payment in a certain direction. Is it inbound to node A or is it inbound or outbound to node B? It does these assertion checks based on some of the exposed APIs that you have in the network. Next thing that this test does is that you you have this function called next event that you can use to get synchronously get events as they happen within the network or within the node actually. And ideally you should have none because nothing of note has happened at this point. No event should have been generated anything because one, you haven't opened a channel, you haven't sent anything, you haven't done anything, so you shouldn't have any events. But next thing afterwards is that okay, node A wants to open a channel to node B. So um, with the necessary funding starts, uh, it, it opens an announce channel, giving like the exposed API and the necessary parameters that it needs. That's like the node ID for node B, the listening addresses for node B, funding amount, and whatnot. After doing that, if you make an assertion call to like know whether node A has node B as its peer, then it should you should assert to true, right? Because you have opened a channel to node B, so node B should be amongst your list of peers. Um, yeah. Afterwards, there are certain events that you should expect to happen. There's a channel pending event. Those things, like there is a like when you open a channel, there's a funding transaction that gets created. Uh, the funding transaction gets created. We broadcast it to the network. It gets mined. It's in a block, and within um, the pre-agreed block block time that the nodes have agreed that we're going to wait before our channel becomes operational. Then, for example, by standard, it's like maybe 6 blocks. That's enough depth for you to now say, let me start operating my channel. But there are nodes or peers within the network that can agree to do like a shorter number. In some cases, there are 0 confirmations. Like the moment I see this network and this transaction in the network, and so
It's good.
okay, yeah, that's what I was saying. That when you have the funding transaction broadcast to the network and it has a sufficient amount of depth, especially the depth number pre-agreed between the two nodes, then you can proceed from there. You'd expect to have an event that tells you, hey, we have an event that says, okay, there is a funding transaction for this channel that you want to open within the network. We have spotted it, or we have note of it, we have seen it within the network, and so we can proceed. So you can wait for the transaction and then get notified when maybe the transaction has attained a certain level of depth. So in this test, for example, this highlighted section, this is saying, hey, we agree to have 0 confirmation. Like we don't care for the transaction to have in mind and put in a block before we proceed. Like as long as we can see it somewhere in the network, we can proceed. If that's the case, yeah. If not, then we have to generate blocks and wait until the appropriate number of blocks, the appropriate depths that you need to have before you proceed. So in this case, having done that, you sync your wallet again, and then it's kind of like for the rest of the test, it's kind of like the dance that you go through. You you do some work that maybe needs chain interaction, chain movement. You generate blocks, you sync your wallet, then you proceed. You check the events that are generated, whether the appropriate type of events that are generated for the particular action that I have just taken on the node. If it is, then you proceed. If it's not, essentially the test shows that okay, a node can do things like open a channel. It can wait for confirmation. It can check that it has the funding transaction. It can get a list of its balances and know whether its on-chain spend is less than a certain amount or it's more than a certain amount. Whether it has money that it can spend for its channels. Um, yeah. I think we have covered list balances. We've covered some of the expected events that a channel should get. Then finally, like in terms of like the node B receiving a payment, it can generate an invoice, give the invoice like a description, and say, hey, based on like the type of invoice that was created that I want to receive a certain payment. And then node A can send to match the receive. I don't know if you understand me, but node A can then send because node B generated an invoice that it wanted to receive payment for. Then after it's done that, you go through that dance again. Uh, you check the direction, what is outbound, what is inbound for which node. You make certain assertions about the length of things, be 1 or 0. You expect certain events, whether the payment was successful, whether the payment was received. Um, proceed. I think we have done like the open channel, we've done the payment receive, we've checked that payment is successful and payment was received. So we've done what is, I think, termed the normal operation of the channel. Every other thing is just like maybe edge cases that this test has in place. If you try to overpay, you try to pay a zero amount invoice, stuff like that. So I ideally would have loved to do a debug walkthrough so that as we're walking through, we get to see the values of uh, the values as they're moving and as they're changing over time as the nodes are interacting with each other. But this is much simpler and it gets quickly through this very long test. But the test the essentially demonstrates what is available from the node API, what you can call, what you can use, and I think that is as far as I would go. Every other thing is, I think, within the test here is quite straightforward. It's quite long, so if you have any questions or you'd like more, please let me know. I think for now I am done with this presentation. Okay, thank you very much for. Is there anything that anyone found unclear that you would like clarity on? Something that you would have loved us to talk about, but that we didn't mention? Well, anything?
Yeah, I think it's okay for now. We are following closely.
Thank you very much for setting this up.
Yeah, I think most of them could maybe watch later on YouTube, and as you on Discord, they can maybe share the questions on the server.
Okay. Thank you very much for this. I'm deeply grateful.
Thank you for your time. Appreciate.
Yeah, thank you.
Thank you very much.
I wasn't really sure what to. I wasn't really sure what to prepare because I didn't know whether you wanted a bit more hands-on workshop where people get to set up their own development environments to work on stuff.
Yeah, the thing is, most of the people, it will be like their first time discovering this. So
Okay.
this gives them an overview on how to access things, how to launch things. And I think the question will come when you try things, when you try to build, and that's when people will have questions. So we expect, like what Alphonse said, if they have questions, they will for sure share it in the Discord channel and we will relay them to you for sure.
Okay. I totally agree with that.
Yeah. So do not hesitate to share some links or some documentation directly in the Discord server.
Yeah. I will look at doing that thing tomorrow morning.
Okay.
I'm going to stop sharing my screen now.
Yeah. So I think the stream will end here, the session. So thank you again very much. It was really interesting. Thank you guys for watching. Thank you also to the people currently watching on YouTube. So next learning session, I think, is tomorrow. Alphonse, tomorrow, no?
Yeah. Tomorrow should be tomorrow with Peter on BTK, Bitcoin Development Kit.
Okay, that's great. So thank you again, guys. Have a good night. See you.
Thank you. Good night.